Dear colleagues, my name is Vladimir Chigrinov. This is my pleasure to present my topic today is photoalignment and photopatterning nanosize azodye layers new liquid crystal technology. I represent Hong Kong University of Science and Technology and Nanjing Jinsu Optical Technology Institute in Nanjing, China. So here is a short bio of myself. I am SID fellow, have Zlotovaki prize, and have many different awards. In particular, I have 6 books in liquid crystals and sufficiently high Google Scholar and Web of Science index. And I also have 38 United States patents, and the last patent has been given last. I have a lot of collaborators, not only in Hong Kong, in China, but other countries like Europe, Russia, uh, Sweden, Belarus, and so on, and the States. So my today presentation will be dealt with new technology of nanosize azodye layers, which is photoalignment. I will also tell you about new LCD display technology and some new applications like e-paper, field sequential color displays, and I will also make a special attention for liquid crystal application in display electronics. So for photoalignment, we have published a book which is called Photoalignment of Liquid Crystalline Materials. This book has been published in 2014, and now we are trying to make a revision of this book. As for nanosize azodye layers, we have special molecules which are rod-like, which have absorbance oscillator parallel to the long molecular axis, and which are rotating perpendicular to the polarization of the light, because in this case there will be no absorbance of the molecule. The details of the mechanism are described in Journal Physical Review in 2004. There are also some azodye materials which can be used for supersynth polarizers, and this azodye materials has very high dichroism. So here is a picture of nanosize azodye layers. Thickness of azodye nanosize layer between 1 and 10 nanometers, and it looks like they will rotate, the molecules will rotate to become perpendicular to the polarization of the light, and one of the molecule of azodye nano layer on the surface will change orientation of million of liquid molecules in the bulk. So here you will see the picture of atomic force microscope, and you will see very uniform and high alignment. If you go to the resolution is extremely high, which you can actually check by diffraction gratings. And we come to the conclusion that resolution is better than 75 nanometers, which are on the level of optical equipment in our lab. Also, azodyes can be successfully used not only for glass, but also alignment on flexible substrates. And all electro-optical characteristics are comparable with azodye characteristics on glass substrates. Moreover, the temperature dependence is not very high as usual for rubbing, so we can use a lot of different plastic substrate for liquid crystal alignment. If you like to stabilize liquid crystal alignment, you can put a liquid crystal monomer and then polymerize it, and azodye cannot move inside the polymer net. You can polymerize it using photoinitiator or thermal initiator. And after stabilization, you will have high thermal stability, 24 hours at 100 degrees C, and high photostability for UV light, 12 hours and 100 per centimeter square. So here is a comparison of the table, and the number of ions on the surface or on the bulk, anchoring energy and image sticking parameters are comparable with usual Raben technology, or sometimes is better. Also, we can write a lot of different a lot of diffraction gratings and photonics elements using photoaligned azodye layers. So by making double exposure with changing the polarization on 90-degree, you can write pattern azodye alignment, or if you expose and rotate the plates, you can make so-called Q plates, which we have published in 2011. These Q plates can be efficiently used for optical data. We can also get photoalignment in microtubes and fibers where usual Arabian technology is not possible. And we can foresee many different optical elements in the fibers, like spectral filters, tunable wave plates, tunable gratings, polarimeters, and so on. So, advantages of photoalignment technology, and in particular Azodye Nanosize photoalignment technology, we eliminate static charges and impurities. We have controllable parameters of liquid crystal alignment like tilt angle, anchoring energy, thermal and ionic stability. And we can also foresee new applications where Arabian technology is not possible to use. For instance, liquid crystal efficient alignment on curved and flexible substrate, and also new liquid crystal photonics elements like pattern polarizers and phase retarders, tunable optical filters, polarization non-sensitive optical lenses, and so on. So, first photoalignment has been introduced by Sharp, and they called these technologies UV2A. They made vertical alignment of liquid crystal using photoalignment. And you can see, because we avoid the defects and we avoid patterning of the electrodes, you can see from the picture that photoalignment, which is on the right side, is much better than usual technology for vertical aligned liquid crystals, which are used for TV applications. Also, you can have excellent quality of transmittance versus time using photoalignment technology instead of usual multi-domain vertical alignment technology. So you can make different good things: high contrast ratio, high optical efficiency, fast response time, and this has been done in 2008-9 in Kamiyama Sakai. So here is a picture of liquid crystal TV, which has been which is sold in a Hong Kong shop. And you can see excellent resolution, excellent quality, and excellent contrast ratio. Other applications of Azodye photoalignment technology is optically rewritable paper, where actually you change alignment of Azodye layer on the surface, and then you change twist angle of liquid crystal in the bulk. You actually put some image on the on computer, you transfer it to LCD module, and then you shine at the light and make the image on liquid crystal layer. We called it a new type of Xerox machine because Xerox can be done only once, but here you can do image many times. Dependent on the location of the polarizers, you can have white images on the dark background or dark images on the white background. If you like to see a color image, you can use color polarizers or add fluorescent dopants here. If you do not have polarizer, you don't see the image, so you can use it for security films. We have excellent grayscale for images, and we have excellent resolution for images. And we can also make 3D images for left and right eye, different images. If we make two writing of the two images and then put lenses. Possible applications are price labels in supermarkets, display in plastic cards, and also some other applications. Display on plastic cards, on ATM cards, has been done in collaboration with the laboratory, and now we are working to make special price labels in supermarkets, which can be changed by RF on distance. Also possible to make sign and advertising displays, but if you use this e-paper outdoor, you should have filter to cut sunlight. If you compare e-paper based on photoalign Azodye layers with e-paper using, for instance, by company or top panel, we can tell you that our e-paper is cost effective because there is no TFT driving electronics. It is color triangle, excellent, much better than electronic ink. 5 bits of gray levels are achieved, high contrast ratio, and very wide temperature range, and also can be used in flexible substrates. If you compare the price of our e-paper, optically writable paper, to the cheapest liquid crystal display, because we have no current conducting layer and we have no drivers, it is several times less in so we have very durable and flexible display, lightweight, high quality, wide viewing angles, and the zero power consumption. Now we're working on color e-paper and flexible e-paper, and hope we will show you our results soon. Another application is field sequential FLC. You are well aware that liquid crystal display is not green because we have problems. Polarizers and color filters absorb a lot of light. So you have 100% of backlight in the input and only 5% backlight and only 5% in the output. So you can put the light time sequentially. Your eyes will integrate and you will see the. So you can, for time sequential color, you can use red, green, and blue light, but liquid crystal should be fast enough. And sometimes company Philips propose even not color triangle, but color pentagon to have field sequential color picture. So it should be very crystal materials, which can enable to decrease power consumption about times, and also to increase color triangle. Actually, we think that liquid crystal materials can be much faster if they use photoalignment, if they use special ferroelectric liquid crystal phase. It has been discovered in 1975 by Robert Mayer, and then Noel Clark and Sven Lagerwolf propose surface stabilized ferroelectric liquid crystal mode. But later, with my friend and colleague Martin Schadt, who is the father of liquid crystal display, Professor Pozhdaev and Professor Srivastava, we propose a lot of new electro-optical modes based on photoaligned layers. So ferroelectric liquid crystal is much faster because this is linear electro-optical mode. It can be very, very fast and it can have extremely high contrast ratio. And also the problem of mechanical stability is solved. So here you will see the typical parameters of ferroelectric liquid crystal electro-optical modes, which we call the electrically suppressed mode. So for this mode, we have extremely high contrast ratio. We have also very good contrast ratio, and we have shock-free displays. So we have 130% of color triangle, fast response time, and the reflective field sequential display without any problems. We also have excellent angles of the display. To make gray levels, we use pulse width modulation, so we can make different. And because the thickness of liquid crystal is very small, we have no influence. We have no crosstalk between two neighboring pixels. So for reflective mode, we have 15 microsecond response time and of gray levels, and excellent viewing independence. So here is a display mode, which we have mentioned colors, and we use different liquid crystal, ferroelectric liquid crystal mode, like deformed electric effect. And this mode can produce extremely fast response time, 25 microseconds, easy to get. We also developed new thin film transistors, which we enable to operate with liquid crystal because charging current should be much higher because of fast response time. We use IGZO or low polysilicon transistors. So finally, we get excellent field sequential color displays with high contrast ratio, fast response time, mechanically stable, excellent color triangle. So if you compare our photoaligned ferroelectric liquid crystal mode with other electro-optical mode, we can tell you that ferroelectric liquid crystal can get 120 microsecond response time for plus minus 1 volt per micron. It is also possible for other modes, but they use much higher voltage. So they cannot use, for instance, CMOS backplane, because CMOS backplane with high resolution does not allow to use high voltages. We use CMOS backplanes for ferroelectric liquid crystal. So finally, we have high resolution, fast response time, excellent ferroelectric crystal displays, which can be used also for ferroelectric liquid crystal on silicon applications. We have many contacts with different electronics companies like Jasper, AU, Varitronics, and not only in Taiwan and China, but we have many other companies in US, UK, and so on. We have provided ferroelectric liquid crystal display on LCOS for different applications: military, medical, AR, VR, entertainment, head-up displays. We have presented our work in 2018 SID conference in Los Angeles. So we have presented two types of display, which has excellent response time and large size. And here is myself, and here is my team. Here is my PhD students, and here is Professor Abhishek Srivastava, who continues working in this direction in University of Science and Technology. One of the good application of ferroelectric liquid crystal on silicon is augmented reality and virtual reality, because you can have extremely high resolution, extremely high contrast, and wide field of view. So the market is growing for this application, and many applications are foreseen, like optical network switch, LiDARs, 3D printing, engineering inspection, 3D face recognition, 3D fingerprint, spectral imaging, medical, and so on. So the market in 2025 in China is estimated several billion US dollars, like market for light switch, LiDARs, laser processing, and so on. Also, photoaligned liquid crystal used for new optical elements. For instance, if you put Azodye and then you will put liquid crystal monomer, polymerize it, you can use face plates. You can have A plates, O plates, and C plates. And then you can use these plates for 3D displays. If you write down harmonic scattering, then with proper thickness, harmonic diffraction grating, then you can have only two output light, left-handed circular and right-handed circular light. If you put quarter wave plane, you can make 100% polarizer. So if divergence of light is plus minus 15%, the polarization intensity will not be 50%. It will be about 7%. So you have two layers. One layer is harmonic lattice of Azodye layer, and the other layer is wave plate. So you can considerably improve efficiency of the light for polarizers. You can also use patterned super thin photopattern polarizer for 3D displays, and our recent results showed that we can have extremely high contrast ratio and extremely high ratio. Another possibility, you know that quantum dots can be used for excellent colors of liquid crystal display. But if you put quantum dots to quantum rods, you will not only have excellent color, but you will also have very high efficiency, because the illumination will be perpendicular to the movement of quantum dot rod. So by photoalignment, you can align quantum rods with quantum dots and have excellent quality of new displays. Not only good color, but high efficiency. We can also use it to make red and green light, and we have very effectively align our quantum rods in quantum dots in quantum rods using inkjet printing technology. So changing several parameters of liquid crystal, we can have excellent liquid crystal display. We also can not only align but pattern quantum dots in quantum rods. Very high efficiency, so we can have different types of displays here. And finally, we can get excellent photoalignment technology, very high degree of polarization, and our quantum dots and quantum rods can be not only photoaligned but photopatterned with very high resolution, about microns. So we can considerably improve the efficiency and brightness of liquid crystal display tremendously. And also we can use field sequential color displays for photoaligned ferroelectric liquid. Also we can use ferroelectric, we can use photoalignment technology for security films. So new security films can be seen only under special polarizers, and when you observe only with polarizer, change brightness with rotation of the polarizer and change the picture of the rotation of the polarizer. So here you will see the movie of optical security films. So you don't see the picture without polarizer, but you will see polarizer, then you will see the picture. And you can have extremely high resolution of these movies. Next, I would like to tell you that you can have excellent smart windows. You know that smart windows which can change their transparency if you apply electric field. They can change the transparency from opaque to transparent or from transparent to opaque, and usually people use polymer dispersed crystal films. If we compare our new smart windows with polymer dispersed liquid crystal films, we can see excellent viewing angles of our smart windows, very small driving voltage, and fast response. For instance, we can see that contrast ratio can be extremely high, and we can change the transmittance from opaque to transparent. We put our scattering structure not in the bulk but on the surface of liquid crystal. We can use different design, in plane switching, random alignment structure, PB, phase length array, and so on. So this picture is much better because there is no degradation of liquid crystal, and you will have the same excellent smart window effect. Another application of liquid crystal devices is liquid crystal photonics. So you know that we should control the light in fibers. So we should foresee different liquid crystal photonics elements which can change usually microelectromechanical mirrors, thermo-optical, optomechanical, acousto-optical devices for this application. So we can foresee switches, filters, attenuators, equalizers, polarization controllers, and so on. Moreover, we can use already used liquid crystal technology for its production. So we are working together with liquid crystal with companies, and these companies propose new liquid crystal element, liquid crystal waveguide interferometer, beam steering, tunable filters, and tunable lasers using tunable liquid crystal materials. This is real devices, not just a dream, and they have excellent quality. So if we compare, for instance, liquid crystal variable optical attenuator with other applications, fiber attenuator, MEMS, thermo-optic effects. All the parameters in infrared are comparable, but one parameter, power consumption for one switch, is much better for liquid crystal because there is no mechanical movement. There is just of the molecules. For instance, by changing the refractive index of the cladding, we can change the intensity of the fiber. And if you have Q plates, we can also make Q plates for optical data processing, in particular pattern recognition. If we have digital mirror device, for instance, which has been done by Professor Wai Hu in Nanjing laboratory, we can have high transmittance, broad wavelengths, flexible design, and excellent configurations. So we can write down many different optical pictures, not only on glass, on flexible substrates. We can also foresee beam steering elements if we can get special configuration of liquid crystal. And these beam steering elements can be also done using liquid photoalignment. So, for instance, if you like to change the beam from 0 to -1 to about 4 degrees, you can get very high diffraction efficiency with aligned liquid crystals. Another photonics applications is sensors. I think we can sense 4 Stokes parameters. So we can actually visualize so visible objects. For instance, bacteria in water. Suppose that bacteria has the same refractive index as water, and you cannot see it. But if you see not only color and transmittance, but also intensity of light by pattern polarizer. For instance, here different Stokes parameters can be done as difference of the intensity of different subpixels. And you can do it in a large array, putting on CMOS image sensor. You can get excellent micropolarizer array pattern. So you can visualize invisible objects. Another possibility, you can actually visualize electric field in liquid crystal layer. Or if you can transfer pressure or velocity to electric field, you can also visualize them. The idea is to put fiber break grating in close contact liquid crystal layer. We make this work together with University of New South Wales. And we make polarizing nanogrid layer on the boundary between fiber with break grating and liquid cell. So these sensors already used to sense the pressure in mining in Australia, and they can be also used to sense flow and pressure in pipelines. Another possibility to use liquid crystal is liquid crystal lens. So lens should be compact, lightweight, low cost, and efficient, and it can be used for adaptive optics, optoelectronics, machine vision, 3D displays, eyeglass applications. But if you like to change the focal distance of the lens, if it is mechanical system, you must move the lens. But if you use photoalignment, you don't move anything. You just change the direction of the molecules between two layers, and then you can change retardation, and you can change the focal distance of the lens. So changing the volts between 0 and volts, you can completely change focal distance of the lens, not only for polarized light, but also for non-polarized light. So we get this change in focal distance from about 15 centimeters to infinity by changing voltage between 10 volts. You can also foresee new types of liquid crystal displays. If you make photoalignment and you don't have the polarizers, you can make a lens because special structure of liquid crystal photoalignment materials. You can have a lens, and if you have a lens, you will have such image on the crystal display. If you have Fresnel and LED light, you can get window display. So if you drive the car, you can see some image on your You can also simultaneously analyze a right and left-handed circular polarized light using punch-Banaramberi. So you can simultaneously analyze these lights, because with punch-Banaramberi lens, for right-handed circular polarized light, you will have convergent lens. For left-handed circular polarized light, you will have divergent lens. So you can use this technology for optical interconnects, spin photonics, and trapping. And also we have been working with professor in Taiwan, and she likes to make special glasses for people who has different diopters for left and right eye. So using liquid crystal lens, you can not only make special amount of diopters for your eyes, but you can also memorize it. So this is the future of liquid crystal lens for different applications. You can also use waveguide couple micro-ring add drop filters. So you have 3 wavelengths coming here, and you can like to drop one. In this case, you must make resonance in this micro for waveguide resonance. Finally, I would like to tell you that you can make reconfigurable antennas. So reconfigurable antennas can change frequency and can change direction of radiation. If you like to change frequency, you change impedance of antenna. So you put liquid crystal element here, materials, which are sensitive on megahertz, gigahertz, or terahertz region, apply electric field, change dielectric anisotropy, and so you change the frequency of antenna. So we have already made this experiment, change frequency in gigahertz region. And if you like to change direction of antenna, you can make meta surface with different antenna elements and change phase difference between 2 neighbor antenna elements. In this case, you can change the direction of antenna. So you can have high transparency, reduced payload, reliable antennas, and the reconfigurability can allow SPICE satellites with anomalies. You must have special materials with high dielectric anisotropy, so you can make antennas with this. And these antennas are very promising, and they can be transparent and then can be used for satellites and smart windows. In summary, I would like to tell you that liquid crystal devices for display and photonics are dominating in the market and will be the basic technology for advanced display and electronics in the nearest 10 years. Photoalignment can be effectively used in liquid crystal alignment and patterning for new generation of devices with high resolution and optical quality of alignment, both in glass and plastic substrates, photonics devices, holes, and so on. And finally, I would like to tell you that new liquid crystal devices, including e-paper, field sequential color displays, photopattern, quantum dots and quantum rods, Q-plates, sensors, switchable lenses, smart windows, security films, switchable antennas. And at the end of my lecture, I would like to attract your attention to my book, which is called Liquid Crystal Photonics, which has been published by Nova Science Publishers in 2014. In this book, I highlighted not only different liquid crystal phenomena and electro-optical modes, but I also highlight how liquid crystal with Photoalign, Azodye, and other Photoalign layers can be used not only for liquid crystal displays, but also for photonic elements like switches, polarization rotators, variable optical attenuators, and lenses, sensors, and so on. So finally, thank you very much for your kind attention. And if you have questions, you are welcome to make this. I will be very happy to answer you if you use my email. Thank you very much.